I'm Olivia and I'm doing Workshop 8, Part B, Aqueous, Ionic, Equilibria. Letter A, you're going to make a buffer using acetic acid and its conjugate base. You start with 1 liter of 0.0207 molar acetic acid as the basis for the buffer. How many grams of the acid would you have to add to give you this concentration? So we start with 1 liter, and then we use the molarity to cancel out liters, because we know the units for molarity are moles per liter. So we put 0.0207 molar per liter, and you use the molar mass of acetic acid, which you can get from the periodic table, and we know it is 60.06 grams per mole. So we're going to use that to cancel out the moles from up here. So we have 60.06 grams per mole, and then now we cross out the units and we're left with grams, which is what we wanted. And so we have 1.24 grams of acetic acid in 1 liter of H2O. So we use the liters that we were given in the problem, we crossed it out with the molarity, and then the molar mass to get 1.24 grams of acetic acid in 1 liter of water. For part B, it asks, what is the pH of the solution you made in part A? You can assume X is small. So for this, we have to make a rice table. Okay, so for R, we're going to put the balanced reaction. So we have acetic acid plus water in equilibrium with conjugate base plus H3O plus. So for the initial concentrations, we have 0.0207 molar acetic acid. You don't include liquids in the equilibrium. We start with no conjugate base and no H3O plus. For change, we have minus X for the acetic acid, plus X for conjugate base, and plus X for H3O plus. So our equilibrium concentrations are 0.0207 molar minus X, and then X and X. I'm out of space. So we know that Ka equals the concentration of the products over the concentration of the reactants. We have the Ka for acetic acid here, so we're going to put 1.76 times 10 to the negative fifth and set it equal to, we have X times X, which is X squared, over the concentration of the reactants, which is 0.0207 molar minus X. We simplify that, we multiply, we are assuming X is small, it says it in the problem, so we're crossing this out. Multiplying 0.0207 times the Ka, we get 3.64 times 10 to the negative 7 equaling X squared. Then we find that X equals 6.04 times 10 to the negative 4 molar. We know that pH is equivalent to the concentration of H3O plus. We know that pH is equal to negative log of the concentration of H3O plus, which we know is equal to X. So when we plug that in, we take negative log of 6.04 times 10 to the negative 4th, and we get the pH equaling 3.219. For part C, it asks, in order to make a buffer, you need to add conjugate base to the acetic acid solution. How many grams of sodium acetate would you have to add so that the concentration of the conjugate acid is 0.0194 molar? We know that sodium acetate completely dissociates into acetate and sodium, so the concentration of sodium acetate will equal the concentration of acetate. So we're going to start with, we have 1 liter of solution, multiply that by the molarity, 0.0194 moles per liter is the molarity. And then we're going to use the molar mass of sodium acetate, which we found from the periodic table, and we know it's 82.04 grams per mole. So we're going to plug that in. 82.04 grams over mole, and we're left with grams, which is what we were looking for. which is 1.59 grams of sodium acetate. For part D, it says, using the Henderson-Hasselbalch equation, find the pH of the buffer that you made in part C. So, the Henderson-Hasselbalch equation is pH equals pKa plus log times the concentration of the base, in this case it's the conjugate base, over acid. We know the Ka of acetic acid, like we had above, is 1.76 times 10 to the negative fifth. pKa is equal to negative log of Ka. So we know pKa is going to equal negative log of 1.76 times 10 to the negative fifth. This equals 4.754. So we'll plug that in over here. pH equals 4.754, the pKa we found over there, plus log of the concentration of the conjugate acid, which we had up there, 0.0194 molar, over the concentration of the acid, which we had found in part A, 0.0207 molar. And when you plug that all into your calculator, you get the pH as 4.726.